Hi listeners, you're welcome to the continuation of our online physics tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAM, UTME, WAEC, NECO and NAPTIP exams. Today shall be the 32nd edition of our physics tutorial lecture, and specifically we shall be discussing the concept of gas law dimension. The dimension of gas laws such as Boyle's law, Charles law, general gas equation and so on. I am Bangwade. Now before we proceed, we need to consider the learning outcome of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to state the dimension for Boyle's law. They are also expected to be able to state the dimension for Charles law. They should also be able to state the dimension for Prayer's law. They should also be able to state the dimension for general gas equation. And lastly, they should be able to solve relevant UTME question relating to gas law dimension or dimension of gas law. Now on to the gas law dimension. Here is a table to summarize the dimension of the various gas law, and I shall be starting with the general gas equation. The constants, the first column here represent the gas law, followed by the second column which represent the constant, gas constant, then followed by the third column representing dimension, and last one representing the value of the power of dimension. Now, number one here is the general gas law, whose constant K is given as PV over T. If you can recollect from our previous video 30, there as well as at 31, we talk about the general gas law, whose constant is K equals PV over T. Now, if the general dimension is represented as P raised to power X, P raised to power Y, and T raised to power Z, that means the power of the pressure here is represented by X, the power of the volume is represented by Y, while the power of the temperature is represented by Z. Now in this case, where K equals PV over T for general gas equation, that means P here is having power of 1. Therefore, we represent P as P raised to power 1. Phi also is having power of 1. Therefore, Phi will be represented as Phi raised to power 1. While the temperature being denominator here is having power of minus 1. So, therefore, it will be represented by T raised to power minus 1. So, the dimension for general gas equation can be given as P raised to power 1, Phi raised to power 1, T raised to power minus 1, making the value of X, Y, Z to be, our X to be 1. So if we compare this with the general dimension, then we have X equals 1, Y equals 1, YZ equals 1. Now the second one we shall be discussing here is the Boyle's law. Now the gas constant for Boyle's law is given as PV. In this case, no T is involved because it happens at constant temperature, meaning that the value of T is 0. The power of T will be 0 since no T is involved. If K equals PV now, then that means P ordinarily is representing P raised to power 1, and likewise Phi ordinarily is representing Phi raised to power 1. Because there is no t there, then we'll put t raised to power 0, as we know that anything raised to power 0 is 1. So therefore, the dimension of Boyle's law can be represented by p raised to power 1, p raised to power 1, t raised to power 0. And if we compare it with the general representation of dimension p raised to power x, p raised to power y, t raised to power z, then our x will be 1, y will be 1, yz will be 0, because there is no t in Boyle's law, or because t is constant. Now, having understood the dimension of Boyle's law, the next one we shall be discussing comes from Charles' law. Now, Charles' law, if you can recall, let's say that the volume of a fixed mass of gas is directly proportional to temperature. So, and the constant of proportionality of it can be given as K equals phi over T. In this case, there is no pressure, no P, meaning that the value of P will be P raised to power 0. Now, if K equals phi over T, then, phi ordinarily here is representing phi raised to power 1. Yt being denominator is representing t raised to power minus 1, as 1 over anything will give us minus. So, then, because there is no p, and p is coming first in general dimension, then we are going to represent p by p raised to power 0, because there is no p under the Charles law. Then the phi, which is numerator, will be phi raised to power 1, while the t, which is denominator, can be represented by t raised to power minus 1. So, the dimension of Charles' law is therefore p raised to power 0, phi raised to power 1, t raised to power minus 1. So, if we compare this with the general dimension p raised to power x, phi raised to power y, and t raised to power z, then our x will be equal to 0, y will be equal to 1, yz is equal to minus 1. And lastly here we have the Prayer's law. So Prayer's law says that the pressure of a fixed mass of gas is directly proportional to the absolute temperature, provided the volume is constant. So in this case, there is no volume, since the volume is constant. So our phi will be represented as phi raised to power 0. Now, the constant of proportionality for Prayer's law is K equals P over T. Now, if we want to represent it using the general dimension P raised to power H, P raised to power Y, T raised to power Z, then our P, because its numerator here, will be represented as P raised to power 1. Our phi, because phi is absent, will be represented as phi raised to power 0, while the t here, being the denominator, will be represented as t raised to power minus 1. So if we therefore, the dimension of Prayer's law can be given as phi raised to power 1, phi raised to power 0, t raised to power minus 1. So, and if we compare this with the general dimension, general representation of dimension p raised to power x, phi raised to power y, t raised to power z, then our x will be 1, y will be equal to 0, because there is no phi, y z, which is the power of t, will be minus 1. So having understood the dimension of gas law and its power of dimension, then we can proceed to the sample questions from the UTME. And the first question here to be considered comes from UTME 1982, number 41. And the question goes thus: the equation p raised to power x, phi raised to power y, t raised to power z equals constant is general gas equation when option A is s equals 0, y equals 0, z equals 1. Option B says x equals 1, y equals 0, z equals 0. Option C says x equals 1, y equals 1, z equals 0. Option D says x equals 1, y equals 1, z equals 1, while option E says x equals 1, y equals 1, z equals -1. Now on to solution. You have to recall that for general gas equation, we have the constant to be k equals p phi over t. K equals p phi over t. So since p and phi are numerator here, they are going to have power of +1. Yt, that is denominator, will have power of -1. Therefore, our k can be expressed as p raised to power 1, phi raised to power 1, then t raised to power -1. And if we compare this with the given option, it will make our option E to be the correct answer, which is x equals 1, y equals 1, yz equals -1, making option E the correct answer for this particular question. The next question we shall be considering comes from UTME 1995, number 21. And the question goes thus: the equation p raised to power x, phi raised to power y, t raised to power z is equal to constant is reduced to Charles' law when dash. I repeat the question. The equation p raised to power x, phi raised to power y, t raised to power z equals constant is reduced to Charles' law when option A says x equals 1, y equals -1, z equals 1. Option B says x equals 0, y equals 1, z equals -1. Option C says x equals 1, y equals 0, z equals 1. While option D says x equals 0, y equals 1, z equals 1. Now on to solution. We have to recall that for Charles' law, the following phi of a fixed mass of gas is directly proportional to temperature T. So phi is directly proportional to T. If we introduce the constant of proportionality, then we have phi equals kT. Phi equals kT. Then if we make constant the subject, it will lead us to k equals phi over t. Now in this case, we notice there is no p because pressure is constant. So since there is no p, p will be represented as p raised to power 0, as we know that anything raised to power 0 will be 1. Now our k equals phi over t in this case, therefore the dimension will be p raised to power 0 because there is no p. Then phi, which is numerator, is going to have power of +1. So we have phi raised to power 1. Yt, which is denominator, will have power of -1. Therefore the dimension for Charles' law is p raised to power 0, phi raised to power 1, t raised to power 1. So if we compare it with the general representation of dimension p raised to power x, phi raised to power y, and t raised to power z, that means our x is equal to 0, y will be 1, while t will be yz will be -1. X equals 0, y equals 1, z equals -1, making option B the correct answer for this particular question. Now the next question we shall be considering goes thus: the equation p raised to power x, phi raised to power y, t raised to power z equals constant is reduced to Boyle's law when, I repeat the question, the equation p raised to power x, phi raised to power y, t raised to power z equals constant is reduced to Boyle's law when a s equals 1, y equals minus 1, z equals 1. Option B says s equals 0, y equals 1, z equals minus 1. Option Z say x equals 1, y equals 0, z equals 1, while option D says s equals 1, y equals 1, z equals 0. Now into solution. For Boyle's law, you remember that the volume of a fixed mass of gas is inversely proportional to P. And if we introduce the constant of proportionality, we have phi equals k times 1 over P. So if we make k the subject, we have k equals p phi. So if k equals p phi for Boyle's law, that means there is no T because the temperature is constant. So since there is no T, T will be expressed as T raised to power 0. Now in this case, that k equals p phi, both are positive here. That means P will be expressed as p raised to power 1. V will be expressed as phi raised to power 1, while T that is absent will be T raised to power 0. And if you compare this with the general representation of gas law dimension, which is P raised to power x, phi raised to power y, T raised to power z, that means our s in this case will be 1, our y will be 1, while z is 0, making option D the correct answer for this particular question. Now on to practice question. The first question here for your practice comes from UTME 2014, number 1. And the question goes thus. The equation p raised to power a, phi raised to power b, t raised to power c equals constant is reduced to Charles' law when dash. I repeat the question. The equation p raised to power a, phi raised to power b, t raised to power c equals constant is reduced to Charles' law when dash. Option A says a equals 1, b equals 0, c equals minus 1. Option B says a equals 0, b equals 1, c equals 1. Option C says a equals 0, b equals 1, c equals minus 1. Option D says a equals 1, b equals 1, c equals minus 1. Expected answer here is option C. Then the second question here for your practice goes thus. The equation p raised to power a, phi raised to power b, t raised to power c equals constant is reduced to Boyle's law when, I repeat, the equation p raised to power a, phi raised to power b, t raised to power c equals constant is reduced to Boyle's law when dash. Option A says a equals 1, b equals 0, c equals minus 1. Option B says a equals 0, b equals 1, c equals 1. Option C says a equals 0, b equals 1, c equals minus 1. Option D says a equals 1, b equals 1, c equals minus 1. Now expected answer here is option A. Now our next video will be on heat and vapor with sample questions and solution. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you with more interesting lectures on subjects relating to UTME and SSE, especially on physics. Thank you.